Hello guys, welcome to Goza Designs channel. If today's is your first time in on this channel, kindly consider subscribing because every week I'm going to release one video about AutoCAD 2D and 3D and also some other softwares like Teclac Structures, SolidWorks, Start Pro, and then Logitraz. So if this makes sense to you, kindly hit that red button, subscribe, so that you wouldn't miss any of my videos. All right. Now let's jump into today's video. This is a structural steel platform that is intended to support a poly tank, as we can see here. And then we also have some cut ladder here that will enable us to access the top of the this level of the platform for maintenance purposes or any other reason. Is that right? So what we are going to do is that we are going to separate this series into three. We are going to segment it into three sections. All right. So today is the first part, and we are going to draw the columns and then the bracing beam, and then in some later part we will continue with the remaining items. Is that right? So the structural steel platform is basically made up of four columns, structural steel columns, okay, hot roll sections. And this is a UC 152 by 152 by 23. This designation is actually a British standard, based on British standard. 152 is the distance of the width of the section. The other 152 also stand for the height of the section, and then the 23 actually means the weight of the section per kilogram. The weight of the section per the weight of the section in kilogram per meter. Is that right? So it means if I take 1 meter length of this section, it weighs 23 kilograms. Is that right? So the designation that is 152 by 152 by 23 simply means that the 23 at the end represent the weight per meter length. So it could be 152 by 152 by 46. Then it means the 46 the weight in kilogram per meter length. Is that right? So let's jump into it right away. So let me open up a new worksheet of the AutoCAD. This is the interface of the AutoCAD. So this is basically a 3D modeling interface. Is that right? So for one way or the other, for one reason or the other, if your interface is set to drafting and annotation default, when you open AutoCAD, this is how it's going to be. This is the interface of the 2D. Is that right? 2D and then 3D. The only difference is in these two is that you see when you look at the left upper corner here, you will see SE isometric. Is that right? And then beside it, we have realistic. Realistic. Is that right? So let's click on the SE isometric. You realize that we have top, bottom, left, right, front, and then back. These six views actually represent the six faces of a cube in a space. Okay, so these three, if anytime I activate any of these six views, it means I'm in a 2D plane. I'm in a 2D plane. Is that right? But when you look at the SW isometric, which simply means southwest, southeast, northeast, and then northwest, it means I am in the space, which means 3D. Is that right? So anytime if I switch between any of these to any of these, then it means I'm moving from 3D to 2D, okay, or 2D to 3D. The interface is still the same, but it depends on the views or the faces of the object of the drawing that I'm looking at. Is that right? And then that is that. And the realistic here simply means I have 2D wireframe, I have conceptual, I have hidden. As time goes on, when we have modeled some things, we will try and figure out the differences in between all these ones. Now I have decided to take SE isometric, which stands for southeast. Is that right? Now, the most important is, first of all, you must master the 2D before you jump into 3D. Is that right? If you need some polishing in 2D, or you have some challenges in 2D, kindly put that in the comment section below so that I can address it in the coming videos. Is that right? So let's start. But as I did said, as I did say, the most important is the orientation of these three axes, the X, Y, and then Z axis. Okay. So what I'm going to do is that this is the section, this is the plan view of my structural steel platform. Okay, the total height is 955, and I must also say that uh, for the purpose of this video, all the dimensions are in centimeters. Okay, not in millimeters, but rather in centimeters. So the total height of my structure is 955 centimeters. In other words, that is 9.55 meters. Okay, high. So the distance between the center lines of the columns, or the axis, the various axes, is 240 by 240. So ideally it's a square. So I have two axes here and then two here. Okay, so what we are going to do is that, as we said, that the section of this column is UC 152 by 152 by 23, right? Let me just take some quick dimensions here. From here to here is 152 is 15.3. The thickness of the flange is 0.85, and then that of the VIB is 0.6. Okay, I'm not so sure unless I make reference to the catalog to check the exact thickness of the VIB. Just wait a minute, let me check it here. Pardon me for some few seconds. You see 152 by 152. Okay, it's here now. You see 152 by 152 by 23. So what we are going to do is that, let's start right away. So I have my X, Y, and Z. So these three axes is the most important, and you must, once you know the position, you know how to manipulate these three axes, then it means you can easily work in the space. Okay. Um, let's start. As I said, I will first of all draw my square, okay, which simply represents the distance. So to draw that, the shortcut for a square or rectangle is RAC. All right. So RAC, enter. So I must also specify that in AutoCAD, space bar and then enter play the same role. They play the same role. So I'll restart it again. RAC, enter. Then I will click for the first point. Then what I'm going to do is I will specify the center to center is 240, right? 240, enter, 240, and something is gone wrong. RAC, 240, enter, something is not right. RAC, something is not right. 240, enter, 240, enter. It depends on the orientation of my axis. So what I'm going to do is to change the position of this axis, I will use UCS, UCS, first point, first and second. Okay, RAC, enter, enter, 240, enter, 240, enter. So I have my square. Okay, to cross check, you can just pick the dimension. So from here to here is 240, from here to here is 240. All right, so I have the center point, the four corners of my structural steel platform. Okay, so I'm now going to start drawing the section of the column. So what I will do is, as we said, that the thickness of the flange of the section is 6.8 mm. 6.8 mm. In other words, that is 0.68 centimeters. So what I will do is RAC D enter, RAC D enter on X axis, 15.2, enter, something is no, D enter, 15.2, enter, and then the thickness of the flange is what is that? Thickness of the flange is 0.68. All right, then I click enter. I can simply move this. To move it, you select the object, you press M, enter, which is a shortcut for move, or otherwise the move command is here. All right, you can select it. After that, you select the object, you right click, then you start moving. Okay, so we are going to be using F8 to activate orthogonality function, and then F10 for the polar. Or otherwise you can see it here. You can deactivate the orthogonality here or activate it here. Now the orthogonality is activated. Let's see the difference. So if I select this, I want to move it. I can either go this way or this way, perpendicular on a line that is along the axis, but which is perpendicular. I can't go at an angle. I don't know if you get my point. But as soon as I deactivate the orthogonality function, you can see that I can move freely in the space. Is that right? So let me specify this point to be the first point. Okay. Let me have a look at my structure again. So I have the line that is 10 towards that side, is wall position. So what I will do is I will try to draw the vib, the section of the vib as well. So the enter. So let's see what I will do is it's also 15.2. The thickness of the vib is 0.61. All right, enter. So I can easily rotate this in my plane. The command or the shortcut for rotate is RO. Okay, RO, enter. Then I stand here. Then I can now activate my orthogonality to make sure that I'm rotating this at 90 degrees. Okay, to avoid any inconvenience or mistake. Is that right? So I will just place this here. I will mirror this, ME. Shortcut for mirror is MI. Okay, MI, enter. So I'll do this. Then I have my section almost ready. So the rest that I have to do is only I'll move this from here to here. Also from here to here. Okay, then I can now trim. I want to trim this section. Okay, so what I'm going to do is I can choose trim here. Okay, but I prefer the shortcut to make things a little faster, because ideally your left hand will always or constantly be on the keyboard. Okay, with your index finger on the space bar. So as I said, the space bar and then the enter command, and the enter key, they play the same role in AutoCAD. So with my index finger on the space bar, it's easy for me, and the remaining of my fingers on the keyboard. Okay, and then my right hand is always for the mouse. Okay, so I'll just strike TR on my keyboard, TR space bar, then I'll right click, then I can trim. Okay, I have already trimmed that place. I'll trim here too. So what I'm going to do is I want to convert this into a polyline or a single or a unit, a single line. Okay. So I will select all the units. Then I have to join them. I have to use the command that is called join. Join. Okay. To join something, I think the shortcut is only J, enter. J like to join, enter. Then you press the space bar. Then you realize that this becomes a single unit. Okay. So what I'm going to do is that AutoCAD can easily notify me if I'm at the center of gravity of this section. Okay. So I can just pick this and place it in the corner here. All right. So what I will do is the total height of the structure. The total height of the structure is is 955, including, let me see, 955, including the height of the base plate. Okay, including the height of the base plate. So from here up to here is 955, including the thickness of the base plate, and the thickness of the base plate is 1.6. Okay, so I'll come back here and then extrude this at a height of Control Z. I'll select it, extrude. EXT is a shortcut for extrude, or otherwise I can easily change this interface into 3D modeling. Okay, because if you are new to AutoCAD, if you are a new user, you might not be conversant with the shortcut, so you may like to go with the icon, locate the icon. So the extrude command is right here. So you select extrude, you select the object, then you right click, okay, enter. Then you can specify the height. So we said the overall height of the column is 955 cm, including the thickness of the base plate. So what I'm going to do is that I'll do 955. I'll take the thickness of the base plate out of the 955, 1.6. So I have a distance of 953.4. All right. So I will do that. So my column is right here. I can easily change the color by maybe mode, just pressing property, PR, enter. PR, enter, you select it, then you come here, you click by layer, then maybe blue color. I like blue color, okay? So any color of your choice, not necessarily any color of your choice, but a color that you must make sure after printing, it should be able to show on a white paper wall, okay? For to facilitate the this in the for to enable the fabricators on the site to easily, or the workshop to easily read the drawings, okay. I wouldn't prefer, or I wouldn't advise you to use yellow color, yellow color yellow color if you don't have any proper printer. If the quality of your printer is not that nice, I don't advise you to use yellow color, okay. And some of the colors I might be specifying as time goes on. Okay, now what I'm going to do is that I will move this up by selecting the column M, enter, then upward 1.6. Okay, don't forget the thickness of the base plate is 1.6. So what I'm going to do is I will draw a rectangle, RAC. So from this corner to this corner, okay. So I will select it again, then E, X, R, T, press pull 1.6 downward, okay. So now I have my base plate ready, so I can just change the appearance here. So this is the realistic appearance visualization, okay. So I will enable the 2D wireframe option. So this is what I have here that will enable me to have a clear picture of my this thing. So what I'm going to do, I'm going to create 4 holes, okay, for the anchor bolt. So I will first of all draw a center line, construction line. To draw a construction line, what we are going to do is that to draw a construction line, before then I will like to move my UCS on top of the base plate to facilitate things. Is that right? So I will draw a construction line. The construction line is actually an infinite line, and the command for that is XL. Okay, XL. Then I will just hit my space bar. Then I will stand in the middle of my base plate here. Can stand in the middle of the base plate here. I will draw the first line. Then I will stand here. I will draw the second line. So what I'm going to do is that the distance between the base plate, when I look here, is 7 cm, okay, 7 cm, and the diameter of the hole is 2.2 cm. So in other words, this base plate will be using 4M18 bolt, 4M18 anchor bolt for this hole, okay. So it means that we are having a clearance of 4 mm, yeah, 4 mm. This is necessary so that to enable the leveling of the column during erection, okay. So what I will do is I will come back here, then I will offset these lines 3.5 centimeters at each side of the line, okay. So to offset, the shortcut for offset is O, enter, okay. So 3.5, enter. So I will select this, right, left, okay, right, left. Then after that, I will just locate the intersection of of these lines, see enter, okay. AutoCAD will definitely notify me if I'm at the intersection of these two lines. So I click there, then D, enter, 2.2, enter. So I have my first circle. I'll just copy the circle to the other necessary intersection lines. The lines are many, but to make sure you locate the right listen, okay. So I have 1 point here, I have 1 point here, I have another point here. So that is not a big deal. CO for shortcut for copy, I will hit the space bar. I have one line here. one intersection here and then one here. Okay, so I can delete my construction lines now. Be very careful, don't delete this square that we did draw at the beginning. Okay, so now I can activate the realistic mode, and then I will use the orbit command to actually turn my object in the space so that I can properly drill the hole. Now I want to drill the hole in the base plate. Okay. Now the command that we normally use to drill these holes or to create a void in the material is, or to create a void in the material is press pull. Press pull. The icon of press pull is right here. So as I said earlier on, if you are a newbie to AutoCAD, be paying much attention to the dissing, the icons for easy dissings, localization of them. Or me, I prefer the shortcut. Okay, I prefer the shortcut so that I can make things a little bit easier and faster. So PRESS, enter. Then I will come here, right in the circle. Make sure you are in the circle. Then, because if you are not in the circle, uh it might not do well. Okay, so go right in the middle of the circle, you click, then you go downward. If you like, you can specify the thickness of, you can specify the thickness or the height along which you want the press pull to travel. Assuming maybe we just want to counter bore this base plate, then it's necessary I specify the distance by which I want it to be counter bored. Is that right? But now this one, I just want to drill it through. Okay, it's a true hole, so I can just drag it downward because there is no material in it. When I click, it will create the hole. Okay, I click here, then that it's simple as that. But if you face any difficulty, do not hesitate to leave some comment in the comment section below. Okay, so I'll do the same thing here. Press pull, select here, I'll go down, enter, select here, I'll go down. Okay, so after that, I can easily delete my holes. Okay, the circles that enable me to make to create the holes in the base plate. So I have my first base plate and then the column that is ready. All right. So what I'm going to do now is, we have some other holes here. Okay, so let me see the way it is. So we have some holes here for the column. We have some holes here for the column, some holes here also created in the flange of the column. So from the beginning, before we start moving these things around, before we start, we're actually going to copy and paste the column, the rest of the column, if we are able to do one. Okay, so the holes, I need to locate the position of these holes. So when I look at the front view, uh, from the base of the column, from the base of the column, as in from here to the center of the base plate, is 275.75. Okay, I will note it down, 275.75. Okay, 275.75. And then from there to the next level is 285. Okay, it's 285. And then I think from the center there to the next level again is also 285. 285. Okay, so let's actually look at the details of the colon so that we can have a fair idea about the sizes of the distance of the so let me see, from here to here is 32. Okay, so when I look at the base plate, this is the size of the base plate, 32, 15.3, and then there is a distance between the anthrax between the holes is 7 and then 25. Okay, so let's come here to our plan view. So what I'm going to do, the first thing is we are going to create a hole on this flange of the column. So it's important our XY plane should be parallel or should be on this surface. It's very important. Other than that, you will face difficulties in creating the hole. Okay, so to move the X and Y plane onto this side on this side of the flange, what I'm going to do is I will just use the shortcut of UCS, or better still, you can use this command. Okay, this command 3 point. You can specify this in the position of XYZ plane by using 3 point. Okay, so that shortcut is UCS. Okay, UCS, enter. Okay, so I want the origin of my ag of my this thing of my co- uh, I want the origin of my distance to be here. So I will click here. So I want the x-axis to be directing towards this direction, and this also towards this direction. Is that right? So now I'm ready to go. Okay. So what I'm going to do is I will draw a construction line first. So from the base, I think it was from here. Okay. So what I will select it. Offset is 275. All right. 275.75. Okay. Enter. So I'll move it toward the distance. So now I am here. So what I'm going to do is I will offset this. No, the distance, the anthrax is 25. Okay, it's 25. So 25 into 2 is 12.5. So what I'm going to do is I'll come here. I will offset this 12.5 at each side. Is that right? Oh, enter. 12.5. Enter. Bottom and top. Okay, so I'll draw another center line, not here, XL, still the construction line. Okay, so now I'll specify, I want to draw a line in the middle of the flange. Okay, so what I will do is there is this option within AutoCAD which is really vital. Okay, I think I can just specify the midpoint between 2 points, but let's not use that. I can just come down here and click here. So I have my distance. So I will still offset because the distance between the distance is 7. So offset or enter 3.7 at each side. So I will select this line, select it, left. I will select it again, right. All right. So what I'm going to do is the diameter of the hole is what? It has escaped me. Let's just make a quick reference, guys. Okay, we are actually going to use M18 bolt. So the diameter of the hole in the connection plate is 20. Okay, in other words, 2 cm. So C, enter, shortcut for circle. So I'll stand here, D, enter to specify the diameter of the circle. So 2, enter. All right. The enter, I'm actually hitting the space bar. So because I did tell you that they both enter and then space bar, they play the same role in AutoCAD. Okay, so I have one here. Okay, so what I'm going to do is I'll copy this, CO, enter. So I'll specify the center here. You remember we said from the center of this uh, uh, cap plate to the next one is 285. Okay, so what I'm going to do, I will just specify 285, and then the next one is also 285. So 285 into 2 is 570 cm. So I have sets of hole here. What happened? Control Z. I should have maintained this CO from here upward 285, enter, 570, enter. Okay, let me see the position of my holes. They are right here. Something went on wrong, but it doesn't matter. Can just delete them here. Okay, I'll just use those that are visible for me. Visible, those that are visible. These ones were the first ones that I made. I didn't focus on the thing. Okay, so let me activate it. Yeah, so I have my holes right here, so I can just delete these lines because I'm done with them. They were just to enable me. So we are now going to press pull again to create a hole in the flange of this column. You can select this tool. You can select the press pull tool by using the icon, or you can simply use the shortcut press pull. here. Now you have to specify the thickness. 1, enter. 1, enter. 1, enter. 1, enter. Okay. So now I'll move on to the next one. Do the same thing. Do the same thing. I'll do the same thing. Make sure you specify the center of you locate this the interior part of the hole. Okay. Okay. Now I'm done. I can easily delete these holes now. The circles, I can delete them because I'm done with my hole. Okay. So now what I'm going to do is can delete this line as well. Okay. So now my column is ready. Okay. So I can easily mirror this 3D. We are going to use 3D mirror. Okay. 3D mirror. I want this column to come into this position. So the mirror plane will be, the origin of my mirror plane will be here. The first axis of the mirror plane will be here. And the second axis of the mirror plane will go this way. Enter. Then my column will be right place here. So you will notice that there is a hole on this flank, and then there will be a hole on this flank. The reason why I didn't copy, I have to mirror, is that the hole is on this flank. So if I copied it, you realize that the hole on this flange, which is supposed to be on this flange of the column, would rather be here. So that is why I didn't copy, but I did mirror it. Okay. If that makes sense, you consider watching the video to the end, because I have something amazing for you. Okay. By the time you finish this video, you might also be able to model some basic things if you're a newbie, or you might learn some new tricks if you are an advanced or an intermediate user of AutoCAD 2D and 3D. Is that right? So let's continue. And also don't forget to hit that red button that says subscribe below the video. Okay. And also, if you have any comment or you need any clarification, do not hesitate to send me a mail on gozadesigns@gmail.com. That will be specified in the description below. Or you can also leave a comment below. Okay, so that next time if I want to make a video, I will look up to those comments and then address maybe your queries by making a new video. So let's move on quickly. We have our two columns right here. So what I'm going to do now next is to model uh, this connection beam. Okay, to model this connection beam. So the thickness of the connection plate is from here to here is 1.4. So the distance from here to here, the actual length of the column is 221.7. Excuse me, my pen fall on the ground. I have to pick it up. Yeah, I'm right back again. So let me write down the distance, the effective length of the column, which is 221.7. Okay, exclude the thickness of the base of the cap plate at both end. And I want to specify that this beam is also made up of the UC 152 by 152 by 23. Okay, so what we are going to do is that if I come here, you see the is actually the abbreviation of universal colon. Okay, universal colon. Sometimes they do the designation says UB. Okay, UB is actually the abbreviation of universal beam. So don't panic anytime you see those designations. They means actually nothing. So what I'm going to do is that I needed a section. Okay. So I'll draw a rectangle, D, enter. So on y-axis, the thickness of the flange of the column was 0.6, 0.68, okay? Enter by 15.2, enter, okay? And then the VIB is D, enter, 15.2, enter. The thickness of the VIB is 0.61, enter, okay? So I'll move this here, I'll move this here, then I'll mirror MI to mirror from here to here, enter, okay? So I'll quickly stretch this here, hook this point, and then just stretch, drag your mouse, and then you can easily stretch. Then after that, I need to trim. So TR space bar, then right click. TR space bar and right click, okay? So let's move on. Now I have my section ready again. So I'll just click J, enter, okay, to make it uniform. This time around, I have to look smart by copying the section down so that the next time if I need it again, I'll just use it, okay? So I will have to extend this, okay? And the distance that we did write down was 221.7, enter. So I have to rotate this now. Now we are in a space 3D, okay? I can easily rotate this because the XY plan is parallel to the section of the beam, of the distance of the of the beam. I can easily rotate it like 2D by just using RO command. Okay, no, it wouldn't work this way for me. It wouldn't work this way for me. Let me use the 3D RO, the rotate command 3D option. Okay, 3D rotate, then, or otherwise instead of using this one, you can just it's right here. Okay, the 3D option for the 3D. So 3D rotate, I'll select this 3D rotate. Now I need to specify the axis along which I want to rotate this beam. I want to rotate this beam along the red axis. Okay, so I'll click it, I'll select it, then I'll move it upward 90 degrees. Okay, so it's right here. Now I have to model the cap plate. Okay, the cap plate, I'll make it RAC D, enter. The thickness is 1.4, enter. So RC D, enter. The width is 15.2, enter. 32 is the height, enter. Okay, so what I'll do is I will just extrude it backward, 1.4, enter. So on this I'll draw a construction. Now I want to create holes in this. So what I will do is I will offset this 12.5, both top and down, top, down. I will offset this 3.5, left, right. Now I will use the C command to draw a circle C. Now D, enter, 2, enter, okay. So I will just copy this circle, CO, for copy here, here, and here, okay. So I can just delete these three lines, these construction lines. Now I will use press pull command to create a hole in this, okay. So I can just move this here so I can delete the holes that enabled me to make the modeling. Now I can move this down here. Now let's do something here. I need to activate the 2D wireframe option so that I can see the lines wall. So M, enter. Now I want to pick the middle of this base plate, and I know that is somewhere here, but exactly where I cannot tell. So what I'm going to do is, after selecting the cap plate, now enter for the move command. Once the move command is activated, what I'm going to do is you press shift, then you right click. Then AutoCAD will give you this multitude of options to choose from. So I want to specify the midpoint between 2 points. So I'll select that option. I'll click here, from here to here. So I've picked right it there. Now I still want to place this between this point and this point. So what do I do? I will still hit shift and right click again. So midpoint between 2 points, select it, first point and second point. All right. So if I come back, I activate my realistic view, you can see it right here. So if you don't mind for colors, you can actually change the color of the base plate just to the color of the cap plate, and then the that of the beam, to make things easier. Okay, so I like blue color. I will make that of for easy identifications. I'll make this one PR, enter. Sometimes if you have a vast model and you have so many sections in the drawing, you can equally use colors to identify various sections. Okay, you can group sections based on the color, a specific color. So you can decide that, oh, all my UC 152 by 152 by 23 will be blue color. All my UC 152 by 152 by 46 will be red color, and so on. That one depends on the user preferences. Okay, so now I want to model some kind of a stiffener plate here. So what I'm going to do is I need my XY plane to be parallel to this, the thick, this part of the base plate, so that I can model it. Okay, so you see S, enter. So my first point will be here, X should be here, and then Y. Let me make it again. You see S, enter. So I want X this side and Y. X is here, Y can be. Okay, so now what I'm going to do is I can draw a line here, L, enter, from here to here. So let me make it this way. PL, enter, from here to here. It's actually 8.4, so I will go here to 8.4, 8.4, enter. So I will go to, okay, I'll continue again, 2, enter, and then I will join it here. Okay, then I have my stiffener almost ready. J, enter. So let's say the thickness of the stiffener is 10 mm, which is 1 cm. Okay, so I will have to move this from the center here, pick the center, move it here. Okay, so I can easily mirror this. I have to mirror it. MI, enter. No, I need to use 3D mirror. 3D, 3D, MI. So I will specify this point, and this point. Okay, so I have my stiffener right at the bottom there. So I will do the same thing, the same 3D mirror, 3D mirror command, and then mirror it uh, by using the midpoint of this column, of this beam. Okay, I have this point, so I have my two beams and the stiffness. They are ready. So instead of picking these items, I have to make this a sub assembly, so that anytime I pick the beam, I pick it with its cap plate and then the stiffness. So what I'm going to do is I will use Control X and then Shift Control V to paste it as a block. Sometimes this do happen. So when you paste it, you will not even know where exactly it is located on the screen. Don't get mad. All you have to do, simply Control A, then you will see whatever is on the screen. Okay, So I can easily locate it, select it, move, then I'll move it down where my main structure is. So now I can now place this enter. I'll use this whole center as reference from here to here. Okay, so it must be perfectly aligned. Yeah, it's perfectly aligned. If you have time, you can place in bold and see how nice that will look. Okay, let me look at the other side. It's also nice, guys. It's really nice, guys. So let's continue. I will just copy this, CO enter, but I will use the whole as reference, this whole as reference. But you need to be very careful because the point of reference must be really accurate. Okay, so I have to use this point from here to here. Lastly, here. Hope is correct, should be correct. And sometimes this thing that I'm using here, there is, I don't know if you did notice that there is a palette here where I used to select the orbit command, but sometimes it doesn't, it does disappear and come back. Don't really get mad over that. What I normally do is I will just press ORB. It's simple as that. Then it comes, the ball comes, the orbit command will be activated. That is why it's very important to master the distance. How do you call it? To master the distance, the shortcut, so that in case of any eventuality, you can easily be navigating your ways whilst you'll be repairing the icons that you needed. You can you imagine at an interview and there's that kind of pressure, and then you will still be looking for icons to make your work move forward. You can imagine how frustrating that could be. That is why it's very important. If you miss the icon, there is no you will miss the shortcut. Okay, if you miss the line icon, I mean, you can still hit the LI, which is the shortcut for line command on your keyboard, whilst the invigilators will be there mounting other pressures on you. Okay, so it's very important to do this, to master the shortcut. So now I have my two columns ready. So I can just mirror this 3D mirror. I'll pick here, pick here, pick here. Then I have my four columns standing, okay, with the base plate at the necessary levels. Okay, so what I'm going to do now, I'll use the same cap plate here. CO. Don't forget that we actually group it together, okay? So I will just explode it. No, I won't do that. So what I'm going to do is I'm going to rotate this and 3D rotate about this axis 90 degrees, okay? So I'll pick this and place it here. Place it here. So it should be able to, that should be at the same level, okay? It should be at the same level. Because, yeah, exactly. So it is at the same level. So what I'm going to do is, even though it needed some little adjustment, never mind. You can just, I don't know, you can draw a line here. You can draw a line here. Don't mind that, this thing. So why not copy this to replicate it? Okay, I will use this as reference point. So the next one will be here. The next one also be here, guys. For the newbies, as I'm doing it, it might look simpler, but maybe it's not as simple as I'm doing it. Sometimes it might require some kind of practice. If you're a newbie, don't worry. At the beginning it might seem not to be working, but that is okay. It's okay for it not to be working as a newbie, but as time goes on, practice makes man perfect. Okay, but for the advanced and then the intermediate guys, it should be working perfectly for them. So after selecting these three beams, I need to mirror it to the other side. Okay, so 3D mirror. First point, second point, third point, hit enter. Then I have my beams standing. Okay, so what I'm going to do is I have my base plate, my columns already modeled. So when you look at the structure, uh, I'm going to model this plate at the top here. Okay, I'm going to model the plate at the top there. Then we call it a day for today. Then in the next video, we will try to model the cat ladder. Okay, then after that, that will be the end of this series and we move forward. Do not forget to leave a comment below. Okay, if you have any difficulty, just let me know so that in the coming videos I can easily address those challenges and then we will all move forward. So what I'm going to do is PL enter. I will just activate this from here. Uh, Let me do it this way. Why not change the color for this? Just change the color for this. Then at the same time, at this end, I'll do the same thing. No, I actually want my plate to be extended up to this very end. Okay. Yeah. So I need another one here. I think it's ready now. I can just PL. I'll use line command, polyline, PL, enter. So I have this point, this point. It's just a matter of locating the point wall. Then you are good to go. Okay, this point, come here, this point, this point, this point, this point. There is something that is not really sounding, that isn't moving well here. And I think this must move a little further to here, to here, okay, before we come this way. Okay, yeah, and this is the end of it. So I'll just do this. I can now activate my realistic. Now I have my polyline. So I'll select the polyline. Extrude command, value upward 0.3 3 mm. So let's say this is a jacket plate of 3 mm, and then we need to make provisions for it not to interfere with for it not to be interfered by the stiffness of the cap plate, okay, and our beam. So I have my platform that is nicely fitted. So with the base plate, the columns, So if you have time, we can model some bolts and then fit in. That is actually not the purpose of today's video. So guys, it's ready, eh? It's ready. So if you have any comments, just leave it below. If today is your first time, kindly hit that subscribe button so that you wouldn't miss any of my upcoming videos. Okay, so as I told you from the beginning of the video, each week or every week I'm going to release a video, a special video about where I will be sharing my experiences of 2D and then 3D in AutoCAD, okay, and some other softwares like SolidWorks that are also great for modeling, mechanical modeling, and then plate work. Uh, Softwares like Tekla Structures and Start Pro for structural analysis, and then Logitras as well for sheet metal activities. Okay, so it's done. Thank you so much for your attention. We shall meet the next time for the modeling of the cat ladder. Okay, thank you.